All right, so they're giving us an example of what's called bivariate data, and they're asking us what the correlation coefficient could be. Well, let me show you what that is. The correlation coefficient, basically, let me set up some examples here. Maybe I'll do some ones like this. So if you have a bunch of dots, let's say if the dots are perfectly in a straight line like that, that's what we call it an R, but the correlation coefficient is called R. I don't know why we call it R, but that would be R 1.0. If the dots are going down in a perfect line, like that, that's R is negative 1.0. If the dots are going up sort of generally, maybe it's a little tighter, like that, that would be an R value of maybe like 0.85 positive. If the dots are going like down, kind of headed down a little bit, that might be an R value of negative 0.90 or something. Do you see what I'm saying now? And if you have a situation where the dots are just like random, doing nothing, like that, that's R is, well, this is R is 0, or R is 0.1, or R is negative 0.10, you know, super small. So what is R? R is called the linear, let me write it right here. Linear correlation coefficient. Basically, it's a measure of how much the dots form a line. That's what R is. It's a measure of how much the dots form a line. So R goes between -1 and +1. And if the dots line up in a perfect line going up, this is a positive slope. This is a negative slope, right? The line's going down, so it's negative. This is positive. This is a line's going up, positive slope, but it's not as tight, right? It's a little looser. See how these dots are a little bit looser? So it's just 0.85. It's not all the way to 1.0. So 1.0 means a perfect line up, positive 1.0, and negative 1.0, a perfect line down. 0.85 is a line going up, pretty much up, and negative 0.9, these are lined up down. If the dots are just random everywhere, that's basically 0, or you could, you know, say it's 0.10 or 0.01, or it could also be, it could be like a negative 0.09 or positive 0.08, or, you know, positive 0.12, something really small. So basically R goes between -1 and negative 1.0 and positive 1.0. There's where R can be. Anywhere from -1.0 to positive 1.0. R is the linear correlation coefficient. And the more the dots form a perfect line, the closer R is to 1.0 or negative 1.0 if it's a line going down. And so look at these dots, look at my example. So this is a measure, we're trying to compare two quantities. We'll see an example in a second of how we compare two quantities, but for now, let's just get used to it. Doesn't it look like if you were to, what you try to do is fit a line through the middle. Doesn't it look like there's a line going about like that through the middle of those dots? it looks like a line going up. A line up, but not super tight, not super tight, right? So I'm going to go with 0.6 because my dots go up, but they're not super, super tight. You know, they're not like this, really close together, clearly going up in a line. That'd be more like 0.85 or 0.9 if it looked like that, or going down. See how this line goes down? You can see these different lines, right? This line goes down, this line goes up, right? The line goes down to the right. What does it mean as you go to the right? Down to the right or up to the right. So if the line was going down to the right and pretty tight, that'd be negative 0.9. But these dots are a little more loose. They're not clearly lining up. They're sort of lining up a little bit, and they're sort of going up to the right. So 0.6 would be my guess there. So that's what R is, the linear correlation coefficient. We're going to see how you use this in a little bit, but it tells you if two quantities have a linear relationship. What they call bivariate data, two variables, bivariate, two variables, and do they have a linear relationship? Well, the more the dots line up on a line, the more confident we are they have a linear relationship. And R is a measure that now computers and calculators calculate R values for us, and ours will as well. We're going to use the TI 8384 to calculate R values for us. And it's basically a number which tells us how much the dots are lining up. The closer the R value is to 1.0 or negative 1.0, which means the tighter the dots fit into a perfect line, like this and this. If the dots are more loose, then the R value is going to be a little smaller than 1. Somewhere between negative 1 and positive 1. If the dots are even further loose, it's 0.6. If they're really loose, they don't line up at all. It's basically 0, 0.1, negative 0.1, 0.09, 0.08, 0.0. Those are all basically 0. No line at all. And so there we go.